Hello, and welcome to Week 7 of Robotics for All's Advanced Python curriculum. In this week, you're going to learn about memory management and program optimization in Python. And then we're going to try some challenge problems before we begin on the final project. First of all, to understand what memory is and why the management of it is important, you need to understand a little bit about how a computer works. Now, there are many different components of a computer, and they all serve a purpose in creating what you eventually see and interact with. Two of these components that are important to your programs are the memory and the storage. They have similar functions but are set up for different kinds of tasks. So storage is designed to store large amounts of information for a long period of time. The storage on your computer is very likely a hard drive or a solid-state drive if you have a newer device. In this diagram, the storage is a hard drive that's plugged into one of the hard drive bays right here. Memory is also for storing things, but it's designed to store small amounts of information so it can be accessed frequently and quickly. Memory is usually called RAM, short for random access memory, and it's usually located on your computer's motherboard right here in this diagram. You as a user do not usually interact directly with the memory on your computer, but it's almost always being used. For instance, when you have multiple tabs open in a browser, the non-active tabs are being stored in the memory so you can quickly access them again. For another example, let's say you type part of a Word document on your computer but you don't save it. The information is currently kept in memory, not storage. Once you save the document, a copy will be saved into storage, and any future saves will overwrite the original. When you fully shut down your computer and restart it, likely most of the things active in memory are going to be removed, but the stuff in the storage, or the hard drive, will stay. How does this apply to programming then? Well, whenever you make a variable, define a function, or write a class, it goes into memory. Your compiler has limited access to memory, so you need to be smart with how you use it. Python is a high-level programming language, which means it has a lot of abstractions. The details of what the computer is doing is way in the background from what you interact with. It also means that Python has its own memory manager, which will automatically delete objects such as variables and functions from the memory when they're no longer needed. Does that mean our job is done with memory management? Sadly not. Python's memory manager isn't the smartest thing. It only deletes objects from memory when they are no longer in scope. For example, a variable declared in a function is only deleted when the function returns. A variable declared outside a function will remain until the program exits. So for instance, the variable name, right here, will remain in memory until our program ends, even though it's not referenced after line 9, for instance. So we still want to be very cognizant of how we use memory. If we define a million variables all in scope, the compiler will likely run out of memory, causing a memory error and your program to fail. Now let's go over a few practical tips for efficiently using memory in Python. The first one we're going to talk about is string concatenation. Now, when you concatenate two strings together using the plus operator, like here on line 4, it actually creates a new string at a location in memory to store the concatenated string. So it's not very efficient. So for instance, in this program, we have this variable called Toby, or a variable called name, rather, that's storing the word Toby. This is inside memory now. Now we're going to define a new string, which is going to be the product of these two different concatenations. So first, hello, my name is concatenated to the variable name, and that creates one string in memory. And then the second concatenation operation happens, which creates a third string, where nice to meet you is now appended to it. And then MSG, this variable, then is pointed at that string. So effectively, there are 3 strings in memory, just for the simple concatenation operation here. This is because strings in Python are immutable. Once you create a string, it's given its place in memory, and the variable points to that location. If you modify the string in any way, you are changing where that variable points, leaving the original string to sit around in memory, and that won't get cleaned up until it's no longer in scope, or in this case, when our program exits. So it's much better to use string formatting to modify and join strings. So in this case, we're doing the same exact thing. We have the string, hello, my name is, and nice to meet you. And then what we're going to do is instead of using concatenation, we're going to use the dot format method. And when we use the dot format method, these brackets are going to be replaced with this variable here. And so this only puts 2 strings in memory. We have the name in memory, and we have this MSG. And that's all that exists inside memory. So it's it's slightly more efficient than using concatenation. The second example deals with local variables. Python can access local variables a lot more efficiently compared to global variables. This is one way of optimizing your program's runtime. So technically, this isn't about memory optimization, but it actually involves making a redundant variable copy, but what it does do is help reduce execution time, making your program run faster. So in this case, we have a function here called area local, and what we're doing is we're defining a variable called local num inside, and we're going to repeat this 50 million times. We're going to go ahead and just add 1 to this local number, and we're going to run that method. All right, so this is using a local variable. Now this version of the code is doing the same exact thing, except it's using a global variable. So this is declared up here, and then using the global keyword, it's being accessed on the inside. But you can see the operation they're doing at the end is exactly the same. So all it's really changing is how we're going to access it. So now we're going to use a little trick here to figure out how long it takes our program to run. So I'm going to start with the global version of this. I'm going to click into the shell category on this side. And what I'm going to do is I'm going to go ahead and time the execution of this program here. All right, let's see how long this will take to run. Okay, and our program finished, and it took 14 seconds to run this program. All right, now keep that number in mind. We're going to go ahead and do the same thing, except we're going to use the local version of the code. So remember, the operation they're doing here is exactly the same. All that we're changing is how it's accessing that variable, whether it's local or global. So let's go ahead and run this again. And now it's completed running, and you can see it's taken 4 seconds off our execution time. These two programs are doing the exact same thing. They're adding 1 50 million times, but this one took 4 seconds less because it uses a local variable instead of a global one. This happens because Python is set up to access local variables a lot more efficiently and faster than global variables. So in a situation where you don't have to worry about memory, this technique will definitely speed up your execution and make your programs faster. Now, the next example we're going to look at is using built-in functions and libraries wherever you need. So whenever you can, you should use built-in functions from modules or from the regular Python functions, because they are all written to be as efficient as possible with memory and execution time considered. So for example, we're going to create a quick function to find a specific letter of a word in a string. So for instance, we have a string here called bamboozle, and we're going to be looking for the letter Z in it. And we're going to go ahead and do that 1,000,000 times. All right, so we have one method that I wrote here, really simple one. It's just going to iterate across the entire string. And if that current letter in the string is equal to the one we're looking for, we're going to return that index. Otherwise, return -1, meaning it's like an error. All right, and we're going to compare that to the .index method for strings, which, if you guys recall, does that exact thing. It tells you what index that letter is. So first of all, I'm going to go ahead and run this with the code that I wrote for the find value function here. And we're going to go ahead and time it like we did before. Okay, and that program finished running in 3.8 seconds, which is not too bad. It's pretty fast. But now let's go ahead and comment out the code I wrote and instead use the default python.index method and see how long it takes. And there you go. That only took us 0.6 seconds to complete. So we shaved off a huge amount of runtime just by using the inbuilt Python method instead of one we wrote. So like I said before, whenever possible, use built-in functions and libraries for your programs. It will really help with speed up your execution time. Now, something you may have noticed is how we are calling the functions literally millions of times in order to see the effect, even just by a couple of seconds. So, okay, in reality, in your everyday program, the difference in using these methods is going to be very small. It's going to be fractions of a second. And if we're being completely honest, this is going to be a very low likelihood of creating a memory error or a significant improvement to execution time for programs that you'll make in this class regularly, or even when you start programming yourself. So why do we think these tips are important? Well, in this day and age, we have abundant memory on most machines, and the CPUs, the central processing unit, which is located here in that diagram, it does most of the execution of the programs, and they're getting extremely fast, both the CPUs and the memory. So execution time is getting quicker and quicker. Knowing about memory and execution time optimization are still important, because even though the tools we use to solve the problems are improving, so are the sizes of the problems themselves. There's this concept called big data, which is just the concept of the increasing availability of massive data sets regarding anything. And for example, in the future, you might be tasked with programming something that possibly hundreds of millions of users will need to access and run. So at that scale, you really need to be cognizant of how your program is written. because even the smallest inefficiencies will be magnified. Just like we were running this about 50 million times to show that difference. If you're now giving a product to 100 million users, then any small inefficiency will be magnified. In another case, you might be trying to solve a complicated physics problem or biology problem, and you have to use billions of iterations of the program. So you need to be sure that you're using the most efficient possible so the calculation will finish before actual years will go by. Because once you start increasing the size of the problem, the time increases a lot as well. Now, with these tools of memory management and program optimization we have given you, let's tackle some challenge problems before we begin our final project. As you begin the challenge problems in class, keep these memory tips in mind, because we're going to compare your solution during the second class of the week to the final teacher-written solution to see which one is more optimal and which one is using better memory management techniques. So good luck and happy coding.